Hello everyone and welcome back to this lesson on understanding data types. So in your journey during fine-tuning LLMs and deep learning models in general, you'll come across these different data types, namely FP32, FP16, and BF16. So in this lesson, we will try to understand what the differences are between these types and when is it the best time to use each one of them. So the first one we have, and probably the default one that's used in PyTorch, is called FP32. And what this means is the computer uses 32 bits inside your CPU or GPU to represent the number. And they have some kind of a division. So the first bit is used as a sign bit. So it determines if the number is positive or negative. And then there is a part that's called the exponent and another part that is called the mantissa. So a number in scientific notation can be written as some sign, positive or negative, some floating point part times 10 to the power of some number. So the exponent is responsible for this part here, the 10 to the power of 38. And then the mantissa is used to represent the floating point number. So in other words, more bits in the exponent gives you more range for this power, which means it's going to allow you to represent very high numbers or very low numbers. So this is what the exponent is controlling here. And then the mantissa controls this part, which gives you either high or low precision. So how precise are you is defined by how many or how small the steps you can take between one number and the next number. So for example, you can take a step of 0.1, but if you can take a step of 0.01, that's even more precise because you can describe more granular numbers. So moving on to BF16, it's the same thing, except that the number of bits for the mantissa is lower compared to FP32. Same number of bits for the exponent, which means this part here, the exponent part, is going to be the same. And yeah, even this part is going to be the same, but the precision is going to be low. It's not going to allow you to move with very high precision as FP32. So the range is the same as FP32, but the precision is lower. And we will see this with examples in the notebook shortly. Finally, FP16, 5 bits for the exponent, 10 bits for the mantissa. So this one is having lower bits for the exponent compared to the other two, which means the range that this type is able to express is much lower compared to the other data type. So let's see this in action. So in this tutorial, we'll be using PyTorch for the entire notebook. And we will start by creating a tensor of size 100,000 by 1,000. So that's basically 100 million tensor. So we'll be creating a random tensor of this size. And let's start with the float 32 type. So we have this tensor, it's stored in this type. And now let's calculate the size of this tensor. So we'll call the element size. This gives you how many bytes are used to store this element. In this case, it prints 4. So every element is 4 bytes. And this is because a byte contains 8 bits. So we have 32 bits, which means this is 4 bytes. And yeah, this method gives you how many elements are there, which is 1 million. So basically, this is the size in bytes, and then we convert it to megabytes. So here you can see the size is going to be 381 approximately. So this is going to be the size for FP32. We will replicate the same thing, but this time we'll make it FP16. We'll do the same calculation, same code. You can see suddenly the size got reduced by half. So only changing the data type, from 32 to 16 completely reduced everything. Now the downside of FP16, as we discussed in the image above, is that the range of this data type is very low compared to other ones. So it's from this number to that number. So if you try to plug in this number here, in a tensor and store it in this data type, you can do it successfully. But if you increase it by 1, which means you now are getting out of the range, you won't be able to represent it. This is the last number. This is the highest end of the range, and you won't be able to represent anything higher than that. And now the last one, BF16. So again, same code. We are taking in the FP32 tensor that we created before, and then we are converting it to BF16, and we recalculate the size. So you're going to see it has the same size as the FP16. So BF16 and FP16, they both use 16 bits. So it does not matter in terms of the size. It's going to be the same, but it's going to matter in terms of the range and the precision. So to do a quick comparison between FP16 and BF16, let's do something interesting. So let's store this large number. We'll store it as the 3 different types, and we'll compare all of them. And then we will try with a very small number. So when you store the very large number in FP32, you'll see that it was able to be stored very precisely. It is the same number. If you do it in FP16, we agreed that the range of FP16 is very narrow. So it's going to be interpreted as infinity. So it overflows. And if you do it in BF16, you'll see it's going to store it as something very close to the real number. It's not the exact number, but it is something very close to it. And that's the difference between BF16 and FP16. So BF16, it has a very large range, so it can represent large numbers, but it cannot do it precisely. So you'll see there will be some difference between this and FP32. Now, if we do the same thing, but this time we use a very small number. So in order to represent small numbers, you need precision. So now precision is more important than range. So again, for FP32, it is precise and it has a large range, so it can get it exactly. FP16, when you compare it to BF16, you'll see that this one is actually more precise. So if you look at these numbers, 1, 2, 3, 4, so they match. So these two match up to 4 digits, and then the difference is in the 5th. But if you look at BF16, it's just 1, 2, 3 matches, and then it starts to differ here. So you can see FP16 is representing the number more precisely in this case. And yeah, this is the main trade-off between this and this. So FP16 is more precise but lower range, whereas BF16 is more range but lower precision. So that's it about data types for this video. This is going to be important as you work with large language models, because you'll need to calculate how much memory you need in order to load the model. And it's going to be different in training compared to during inference, because in training you need even more memory than just the model weights. You need to store the gradients, you need to store activations, and so on. So it's going to be important. Sometimes you need to reduce the size of the model during training in order to be able to fit that on your GPU. So understanding these data types is crucial. So that's it for this video. I hope you found that useful, and I'll see you in the next one.